I'm talking to Rami Ramaha from Gigamon, and he's going to explain to us the proper way of doing TLS inspection. One of my favorite topics, actually. Rami, welcome.
Hi, Richard. Thanks. Appreciate being here. So we've all seen, Richard, all the spike in cyber threats in the last few months with the pandemic. And attackers, obviously, they are exploring weaknesses, vulnerabilities in software, in remote access and VPN access, what have you. Also, they are looking at ways of stealing credentials, user credentials, using the old book tricks by having people click on links and capturing that information. One thing that is important for organizations is to really inspect that traffic, detect any potential threats, and being able to remediate that. What's critical for organizations is that they cannot afford not to have complete visibility into what's coming into their networks. So if we look at the numbers here, 80% of the enterprise web traffic is encrypted. If we look at 2019, and that number is now 90% in 2020. And at the same time, if we look at the malware attacks, they use encryption and they hide behind encrypted traffic. And again, that number is on the rise. We're looking at about 60% in this year. What's interesting is a lot of organizations, 2/3 or 60% of organizations, they are failing to decrypt that traffic. And they're failing because of they either do not have the right architecture, or they could be possibly do not have the right tools or the right capacity to decrypt and encrypt again. So we've done a survey ourselves, and we looked at the enterprise web traffic, and we looked at the north-south traffic, and we looked at the east-west traffic, which is host-to-host communications. So what we found out is it was very interesting. There's definitely a good number of traffic is encrypted as you go north-south, and a good portion of that traffic leverages the TLS version 1.2, about 78%. That number is actually much less if you look at the east-west traffic, which is again host-to-host. Only 56% of that traffic is encrypted. And again, there's still, the good thing is they leverage the latest, or actually kind of the latest of the TLS, which is 1.2. What we are seeing is the TLS 1.3 is still in the low adoption rate. It's still, you're looking at 20% in the north-south and about 10% east-west. But based on what we are seeing in the industry and what the speculations is, and the inner browsers adopting the 1.3, that number is going to increase about 10% year over year. So what has happened is with TLS 1.3 and encrypting the DNS over HTTPS, these changes created challenges in the network. So these changes actually hide a valuable metadata in the network, which make it difficult for passive tools to inspect that type of traffic. And that's why Forrester said, look, you have 2 years to really prepare and make sure you have the right security tools in your infrastructure to inspect that type of traffic. Otherwise, you are going to really not being able to defend attacks that comes into your network. So if we look at any environment today, you're going to have the network, you're going to have users who are public users coming into your network, trying to consume specific resources, accessing the servers, and you have your internal users. You're going to have the public cloud and the internet, and you're going to have your servers could be whether it's a DMZ sitting in a DMZ zone or sitting in the internal or sitting internally into your network. So the first use case is, if you look at that encrypted traffic, it's the first one that comes in where you have the public users coming into your network. And they are coming into your decryption zone where now you need to look at that traffic. So you need to decrypt that traffic and inspect that traffic. The other use case is about the outbound services. So now you have your internal users are actually accessing the internet, accessing the public cloud, and they're trying to get information, and that's where you need content inspection. And the third one is about the internal services. We talked about earlier about the east-west traffic and the need to inspect that traffic as it moves from host to host. So in the next few slides, I will touch on the first two use cases of the inbound services and outbound services.
Rami, before we do that, is there a difference between the load between TLS 1.2 and TLS 1.3?
It definitely does. So there are TLS 1.3 addresses two things, or two shortcomings if you compare that to 1.2. It's one about the performance, one about the security. So when it comes to the performance, in 1.2, you would require 2 round trips for doing a handshake, where with the 1.3, it's a single round trip to do the handshake, so you cut it now by 1/2. So that's where you have a reduction in latency, and therefore you increase the performance. When it comes to the security portion of it, it's about really simplifying the configurations. So in 1.2, IT has to do configurations, and that can a lot of times lead into mistakes, and that becomes causing some vulnerabilities into that type of setup. So 1.3 simplified that, and it deprecated features like SHA 1, RC4, the DES, and some other protocols as well. So that's the major differences between the two, and that's why we're seeing 1.3 will be taken off in the coming years.
Got it. All better. Good.
So let's look at the decryption challenges. So if we kind of zoom in on what I talked about, you have the inbound traffic coming in into your network. So that's where the public users coming in. So there are decryption challenges, and I'll highlight a few of them here. So if you look at this chart right here, you're going to have tools sitting inline, sitting serially, like the WAF and the IPS, and these tools sitting in line of the production traffic. So you're going to have a single point of failure, but at the same time, these tools need to be running at the same speed or interface speed as your production traffic. So if your production traffic running at 10 gig, then these tools need to be running at 10. If their production traffic running at 40, then you need to be at 40. Now, that doesn't mean the tools are actually running at that capacity. So what you're going to have is probably some performance and throughput issues happening. And at the same time, if there's any things happening to these tools where you need to take them out, or if there's some potential failure, then how simple, how easy you can make these changes. The other part is that how you're going to be able to load share these tools. So you're going to have a lot of traffic coming in from the production network, and you want to be able to have enough capacity, tool capacity, to be able to inspect all the traffic 100%. So these are some of the challenges, if you will, with this particular scenario. It is very similar to outbound services as well. So the internal users going out, they will be facing a similar challenge as well. So as an IT organization, what are your options? So one option is you do nothing. And if you do nothing, that means you are not inspecting. And obviously, we looked at the malware where 60% of malware hide behind encrypted traffic. So that's not a good option, obviously. The second option is you say, look, I want to enable decryption on each security tool. We looked at third-party analysis and testing. Up to 70% of that throughput capacity actually drops on these tools. So now, imagine now the tool that you bought, that expensive tool that you bought, now it's busy just decrypting the traffic, and it's not doing its job by inspecting that traffic. The other challenges with that kind of approach is you're going to have multiple tools, and what that means is the traffic is going to be decrypted, encrypted, and decrypted again, and so on. And that adds latency, that affects the performance, and it makes it difficult for troubleshooting at the same time. The third option is you say, look, I want to bring in a box, a decryptor, and I'm going to plug it in there. So you can do that. There are challenges with that one. That actually, it doesn't really fit in well in terms of really helping in ways of decrypting and adding rich services on top of that. You're actually increasing complicating the security stack, if you will. And the fourth option is here what we're looking at, how you can leverage and use the visibility analytics fabric from Gigamon. So we give you the most flexible way of connecting and decrypting that traffic. The traffic, you only decrypt once. The traffic that comes in, you decrypt it once. You can actually then distribute that traffic across the tools that needs to see it. So you're no longer decrypting and encrypting, decrypting and encrypting. So that's going to obviously improve on the performance and cut on the latency. If you need to troubleshoot, it becomes a lot easier as well. And from a resiliency point of view, you're going to achieve that maximum resiliency because you're dealing with a single platform that allows you to handle the decryption and encryption. This is in line. Our approach is actually in line with what the National Security Agency, the NSA, talked about. It says, do it well, do it once. What that means is the traffic that comes into your network, decrypt it once and encrypt it, and feed it to the tools that need to see that traffic. The minute you start doing decryption and encryption multiple times, you are going to create challenges for your team to troubleshoot. You're increasing the risk in terms of trying to figure out if anything went wrong, and so on. So that's the approach that's being endorsed by the NSA, and that's what we are doing in our solution. So let's look at how we do it. I'm going to dive into a little bit more details, how we do that approach with our inline bypass decryption. So before I do that, I think it's good to step back and take a look at what are the concerns of the networking team as well as the security teams. Because if we understand that, then we can see the benefits that we bring in and how we address these challenges that these teams, or the concerns that these teams have about the inline security solution. So here you have a network, and within that network, now you are adding a bunch of tools. I'm showing here security tools. You can add more tools, like even monitoring tools for the network and the applications. Now, from the network operators' perspective, or the network owners, they have a concern about adding these tools to the network. One is about reliability. What's going to happen if some of these tools go down? Is that going to affect the availability of my network? If that tool, it doesn't perform, it doesn't have the performance that it's supposed to have, is that going to throttle back my bandwidth? Is that going to affect my user experience? And if there's any failure, how quickly can I take it out, and can I put another box in there? So these are the mindset of the network owners. They're trying to make sure the network is always available, running 100%, and there are no performance impact. Now, the security tool owners, they have a different type of concerns. One is they're looking at the network, they're seeing a lot of links, and they're saying, and I have few on my tools, where do I tap into that network? What is the best place for me to tap? And at the same time, they do not want to see every traffic. Not every traffic, it makes sense to them to see, so they want to see a select of that traffic. At the same time, they want to be able to load share that traffic, and they want to make sure if the production traffic is high, how can I add more capacity, and how can I load share that across the different tools? And if there's any specific failure, how quickly can I find this out, and how can I quickly put a spare in place or reroute to that spare?
Rami, just to be clear, one of those load or inspection requirements that you might want to not use is YouTube traffic or a Zoom call,
yes,
right?
That is correct. So you can see sometimes I have a streaming media type traffic. If I have a WAF, as an example, I don't want to be looking at that traffic. Okay, so that I don't want to be taking resources away from the WAF to look at that traffic because it's not important to it. So that's exactly it. So you want to be able to selectively look at the traffic that makes sense to that specific tool. All right, so now let's look at, we looked at the concerns of the network tool owners, we looked at the concerns of the security owners, and let's look at how we address those in our solution. So what you see here is, on the left-hand side is a simple architecture. Obviously, this architecture can be, in real life, is a lot more complicated. But in this particular scenario, just for the simplicity's sake, I'm showing a single path where you have your tools, you have your router, and you have your switches, and so on. And what you see on the right-hand side is the platform from Gigamon and how we would be able to connect to that. So the first thing is, you're going to have a single insertion into the platform. So if you look here, that single insertion that I'm showing, this is your production traffic, comes into the platform, and then it comes out of the platform to the rest of your network, to the switches, and so on. So that single insertion, that makes it extremely simple for IT organizations. You're dealing with a single insertion, and then what you see here on the right-hand side, where you connect all the tools to any ports that you like. We have the physical bypass protection. What that means, if there's any failure on the box, then we continue to pass that traffic. We're not going to bring the network down. The other thing is, you're going to have a lot of customers, a lot of organizations, they're going to have growth in the network. They may upgrade their network from 10 gig to 40 gig or 40 gig to 100 gig. So this interface right here is probably not exactly the same what you see on the tools. So you have this mixed interfaces or mixed speeds between the production traffic and the tools. And that's a great benefit that we're bringing in terms of helping organizations to protect that investment they put in these tools. So if I invested in tools that has, let's say, 10 gig type interfaces, and I moved my production into 40 gig or 100 gig, that doesn't mean I need to move my tools into 40 gig, 100 gig. I can continue to leverage these tools. At the same time, I can add more tools if I need to handle that capacity. We have the logical bypass, so if I need to reroute around any of these tools, then I can do that as well.
Rami, because we're talking about hardware, I always look for evidence of FIPS certification because you're a hardware encryption device.
Yes, excellent point, Richard. I our platform, specifically the HC2, is FIPS 140-2 Level 2 certified, and the FIPS certification is key for a specific market like governments, as an example, and financial institutions. So that's a great point. Thanks for bringing that up. The other one is the flow mapping, and we talked about earlier about not all the tools want to see everything. So what do I do with that? So that's where the flow mapping, now I can route and steer traffic from my production into the tools that I have connected into the platform. Resiliency, as we talked about earlier, is key for both the network tools owners as well as the security tool owners. So what we have here, we have built-in health checks with conditional actions if the tool fails. So the health checks is a way of, we have something called positive and negative health checks. It checks for the tools, makes sure the tool is functioning, is performing, it's supposed to do its role. And if that tool fails, we have the condition to route around that tool and not send the traffic to it. Another thing is that we give you the flexibility to have, you could be having one tool, one link coming in, and from your production traffic and going to the rest of your network. You could be having multiple tools setting in parallel, so you're trying to load share. You could be having tools setting in serially, so what that means is I'm sending traffic to one tool for inspection before it gets into the other tool. So we give you that flexibility to configure the tools the way that you see fit. We also have the N+1 redundancy. And what that means is, for example, if you look here, I have the 3 ATPs at the bottom. So I could have 2 of them active and one of them is a spare or on standby. So if one of the active ones fail, then the spare one will kick in. Another thing is that you can have many to one, meaning I could have a lot of network connections coming into the box, into the platform, and I could have one tool going out to one tool. I could have many to many. That means I could have multiple connections, production network connections coming into the box, and then I'm connecting to multiple tools. So I can have all scenarios that you can think of to give me that flexibility. And obviously we have the SSL engine in the platform. And this is key. It gives you a lot of benefits. One is it offloads the decryption from these tools like the IPS and the WAF that were, instead of them doing the decryption, we could do that in the platform. So now these tools, they are free to do their work, being able to not to drop packets. And by doing that, we actually also prolonging the life of these tools. The other thing is that with the ability to do decryption ourselves, we decrypted once, and I talked about that earlier, and feed many tools with that decrypted traffic. So, for example, I could be having out-of-band tools, and they want to see that specific decrypted traffic, but they don't want to see the whole thing. I want to be able to, for example, mask some of these flows, these packets, because of privacy reasons. We can do that as well. So these are the benefits we bring into with our SSL decryption engine. And lastly, it's how you can manage this whole thing. It has to be simple. It has to be easy. You don't want to be spending, a lot of hours making mistakes. So that's where the UI, the Fabric Manager that we have with the RESTful API allows you to connect to it and being able to manage the whole Fabric very easily, very quickly. So with that, I'm going to give a little bit of view into that Fabric Manager and how we manage things. So here is a way of setting this up. What you're looking at is here actually a screenshot from the Fabric Manager where you could have a canvas, and what you see on the left-hand side, the top left-hand here, is the traffic coming into the platform and how you want to treat that traffic before it goes out on the other end. And then the bottom half is when the traffic comes back from your network, and then what you want to do with it, which is basically a reverse of that, and before it hits out back to the internet. So I'm showing here 4 maps. So the first map is privileged traffic that I do not want to do anything to it. Okay, so I just want to let it go through. I don't want to decrypt it. I don't want to let it through. The second map here is I'm creating a decryption zone with GigaSmart, and then I want to put in what tools want to see that decrypted traffic, and at the same time I want to make a copy of that traffic being sent to some out-of-band tool. The third one is the IP traffic that I want to send to some specific inline tool, and I want to send a copy of that. And the last one is about a collector map, which means if none of that stuff I specified, I want to be able to capture that and collect it and send it out. So this is very simple from an IT perspective, where they can configure this literally in 10-15 minutes versus trying to spend hours and days, depending on the size of the fabric, trying to configure these things with the tools.
Rami, help me understand the size and scale. Just how many devices can be getting these encrypted feeds, and then for the manager, how many of your devices can you manage with one manager, and just that whole scaling issue?
Thanks, Richard. That's definitely another key point. So one of the, obviously, organizations, when they deploy the visibility and analytics fabric, depending on the size of the organization, depending on the number of tools they have and the production network and so on, you could be having, you could have 10 devices, you could have hundreds, you could have thousands of them. And again, it depends on the size of the organization. So you are a service provider. We have service providers who are having thousands of these devices, where now we have the Fabric Manager is able to manage up to 1,000 nodes in a cluster. So, and at the same time, reliability or availability is key. So you can deploy the Fabric Manager in a high availability. So you have one active and 2 of them actually sitting in a standby. So in case the active one fails, then one of the standby Fabric Managers will kick in. So this way you have a continuous ability to manage and operate the fabric.
Thanks for that.
Great. So the last thing I want to cover here is we want to look at the keys. How the keys are managed with our platform. So the first scenario is we're looking at the inbound deployment. And with the inbound deployment, we are sitting in front of the servers. And as we sit in front of the servers, we actually now have the keys installed on our platform. So any users coming into our DMZ zone or trying to access some of these resources, then they see the Gigamon platform, and that's where to them they see they are actually thinking they are accessing the servers, but we are sitting and acting on behalf of the servers and the clients. So we sit in the middle, and that's how we handle that type of communications. It's a little bit different when it comes to the outbound deployments, which means because we do not have access to the keys, then what we do is we actually reassign certificates for each session the user initiates. And therefore, we are sitting in the middle, handling all the communications and making sure there are no pop-ups happens during that communications. So inline, man-in-the-middle communications is where things are today, especially with TLS 1.3 and the PFS support for that. So right now, we're going to look at the demo from Hader. He's going to walk us through the Fabric Manager, how we set these things up. You can see how simple that is, how flexible. You can do these things very quickly, and it can save IT a lot of time.
Hello, everyone. My name is Hader Jiral. I'm Senior Technical Marketing Engineer with Gigamon, and I'll be walking you through the TLS demo in the FM. So what I have on the screen right now, I'm logged into my FM, and this is the dashboard. This is kind of quick overview of all your Gigamon devices and the traffic flows. For the TLS Decryption demo, I will dive right into traffic. So FM is designed in a way where you can dive into different options based on the intent. If you want to look at your inventory, you would go through your inventory. If you want to look at your traffic or you want to set up new traffic, you will go through the traffic. So in my case, since we want to look at the TLS demo, I'll go right into the traffic. I'll go to inline flows, and I'll go to my device where the TLS Decryption demo is set up. So this is the canvas which was shown by Rami during the presentation. This is where we build all our inline related configuration. So once I go inside the configuration canvas, you would see it's very easy to build any config you want. In my case, you can build an inline tool. You can build an inline tool group. So for this particular demo, I've already built an SSL app. I'll walk you through it quickly. So this is an SSL app that I built. So as you can see within this SSL app, I can choose it to be both either inbound, outbound, or hybrid. I've already added my certificates. Then there are very small different kind of configurations which I can fine tune based on the requirements that I have in my environment. So I can add my security exceptions. I can add whitelist and blacklist. I can do policy rules. I can do decryption port mapping. And I can also choose if I have which version, minimum version I need to decrypt. So once I have this whole SSL app set up, I just need to drag and drop just like I have it here. And any inline tool or any inline tool group that I place between this app will get decrypted traffic. And in case I need to get a out-of-band copy, I just need to drag this out-of-band copy map here, and I drop it here, and that's how I get an out-of-band copy. So once I have the whole solution in place, I can just click deploy on the top right corner, and it will deploy the whole solution, just like that. It's so easy to configure and set it up once you know how you want the traffic, where you want to send the traffic. Does the traffic needs to be filtered? Does it need to be, does certain tools need to see decrypted traffic? Are there any tools that do not need to see decrypted traffic? So it's as easy as drag and drop. So in this particular case, I have a map that is filtering out some GTP traffic and send it to out-of-band tool. The other map that is a collector map, it's looking at the rest of all the traffic. It's sending an out-of-band copy to this tool. Then I have my SSL app. And then I have two inline tools. One of them is seeing decrypted traffic, and the other tool is not seeing decrypted traffic. And once you're making the config, it has the flexibility to even choose that you want to decrypt traffic going in one direction and not the other. But in this particular case, I have the decryption set up for both the directions. So once I have the solution in place, I can verify. I can go under statistics to verify how many SSL sessions I am seeing, how many are pending, how many have been intercepted. Then I can also see which certificates are being used to decrypt those sessions. And if I want to dig deeper into those statistics, I can click this button here, and it will take me to the further details where I can see even the source, the destinations. So all in one place to see about all the traffic that you have in your network.
Thanks, Hader, for the demo. So let me just close this with what's the Gigamon advantage. We easily enforce compliance. So with the FIPS 140-2 level 2, the ability to manipulate traffic, mask traffic for sensitive data, and some other techniques, we enable these organizations to stay compliant. We simplify the security stack. Again, with one single platform, you can achieve all the things that we talked about, from resiliency, availability, and offloaded decryption, and being able to reduce the latency, and so on. We enhance the traffic monitoring. By offloading and by making sure each tool can get the traffic that wants to see and give you that 100% visibility, we are enhancing that ability for the tools to see what it's supposed to see. And lastly, we empower the operations team. You have the NetOps team, you have the CloudSec team, the CloudOps team, the InfoSec teams. By empowering them to have a unified, consistent, advanced visibility, their jobs becomes a lot easier, and they can handle any potential issues that may come up on the network, whether it's related to security or performance. That's what we do, Richard, and hopefully that gives you an understanding where we are.
Yeah, it does. That was great. Thank you.